Okay, let's officially start the iPhone application development class for this week. What you're looking at is the first app. What I'm going to do is run through 5 different apps. And just like last week, I have the source code for the app. Actually, I have the instructions for the app put in these little text files, and I'll put the text files underneath the video for this week so that you can cut and paste and experiment. And this is okay. So the learning objective goes like this. I run through the assignment, not really assignment, I'll run through the tutorial for you. Then you will go home, hopefully, and try it out. Because you can't learn anything, especially for this type of course, you can't really learn anything by listening to me. And right now in this particular part of the course, we're in the app development part of it. So I've given you everything I possibly could give you in terms of building up to this point. So now is your opportunity to go home, run through the steps, follow through, and I've pre-built the project so I don't have to do it and stumble through them and with typos and stuff. It'll hopefully all work tonight. And these are the text files that will be included with the video. So this is the important part for you to do at home, is to basically go through and run through this and see if you can get the same application to work. So this first one that you've been looking at is this one here. This is actually just one image, one ball, and it's being replicated. It's being tossed from the top to the bottom of the screen with some random sizes and shapes and components to it. So this is a simple application called Moving Ball, and it's moving. The applications are moving on the screen. The balls themselves are moving on the screen as we see it, which is why it's called Moving Balls. And it's just basically it's to demonstrate a particular feature, and I'll go through it as I'm going through. Each one of them is designed to show you something a little bit different in terms of not only the creativity, but also in terms of the model view controller that I've been emphasizing throughout the course, and the design of the app, as well as the features or what it's demonstrating in terms of functionality. We have one image. In fact, if we look at the image, if we look at the built project, we see the image in here. The built project has ball PNG. Here's the ball that we're looking at, and the ball is going to be tossed several times. So the components that makes up this is also another view-based application. So continuing along with the theme that we had from last week, all of them were view-based. So the ones tonight will be view-based as well. I will eventually move on to some other types. But you're going to add some code to the view controller header file. And the view controller header file, this is what we're going to put in there. So the view controller has the image, and the image is what's going to be controlled. So we have a UI image pointer to the image ball, or ball image is what we're going to call it the ball image. And we have a timer that's going to set some random, throw the ball out there. So otherwise it would look kind of stupid just to have the ball go, one ball go up and down. So. And then we have, and this is the interesting part about this one, is the animation part. So this is all nothing more than a concept of an animation with a timer. And the animation is the effect of the ball moving in a random order. So the on animation complete, which means when it's done, we're going to catch that event, we're going to capture it on the finish, we're going to take the context of it and start it over again, or keep track of it, so we do something with it if we wanted to. So step number one was to create the Xcode project, which I'm going to show you in a few minutes. It's already created. Step number two is edit the view controller. The view controller is going to get this image, this UI image, which is nothing more than the image, control of the image. And then we're going to add on these two particular methods, the methods that we're going to add on. In fact, let me edit this file while I'm doing, oops, I want to edit that one. Put this one in here. And it's going to have these two methods, the on timer and then the oops, here we go. What did I do? Hold on a second. There we go. I deleted it. Did not want to delete that line. So the two methods that we're looking at are the on timer and the on animation complete. So then we're also going to use the interface builder. So you're going to open up the interface builder, and you're going to create the background to white, or change the background color if you want. Bring up the attributes for the background color. Next, connect the file owner's icon to the view icon if you want to do that way, and save it, and then go back to Xcode. So if we look at the view controller for this app, and we know how to get to that by going into the resources and clicking on the moving ball controller XIB or the other XIB file, depending upon which one is being used. I'm going to wait a few minutes because I believe I did click on it. Waiting for it to show. So let me close this simulator real quick here. My memory on this computer is a little bit taxed right now. Oh, here we go. Ooh, actually interesting. Am I running the right window? Mobile moving ball controller. Okay, so this is the controller that we're looking at. It's got an image view on it. And the image view is going to put the image in it. It's going to be controlled by the controller. And the controller is that class here that we looked at. We added this one. These are the two methods that were in that text file I just showed you a few minutes ago. Adding it to the controller, the header file. The implementation of it is the .m file. The .m file is going to have the method bodies that are implemented. And this is the interesting part. This is just the random part of it. So if we look at the implementation, we've got the ball image, which is producing the image that's appearing on the screen. We implement it by a view did load to see if there's any additional painting or anything additional things that we need to do to it. We set the background color. In this particular case, we're setting it to white UI color. The ball image itself is this file that I showed you a few minutes ago, the PNG file. That's giving us that kind of a translucent kind of ball. And then we set a timer, and the timer is going to basically schedule when the ball's. We're going to take the same image and we're going to toss it down several different times in a loop. Actually, is how it's being performed. So on the timer, we build a view from the fake image. Just pretend like that's the image. Using the ball view, and the ball view is the image view. That's the only item that's actually on the canvas for the interface in the interface builder. Then we're using random, as I was mentioning before. This is actually the same as in C++, the random function, because we have to set the random intervals for the size of the ball and also for the direction that it's going to float in. So we have the start x, the end x in terms of the random. It goes from here to here. The scale, which gives us a random. Looks like the seed is going 1.0 to 100%. So it's going in various different sizes. So we can set a flake start position. So each one of the flakes that are coming through will have, and I shouldn't say, I said fake. I meant to say flake in the beginning here. So we are setting a random position to throw the ball from the top to the bottom, random length, and a random size for the ball. So that's how we get that cool effect of those, like, they look like almost like, when they blow through the thing, bubble balls, or whatever you call those things. And it's all basically just nothing more than taking one image and applying a random function to it for these dimensions, for the size and also for the length. We're setting up the flake in the main view. So we're saying view, we're going to add the subview, the ball view. The ball view is the image view. So we're adding subviews to that. And the subviews, as I mentioned last time, I talked about nesting, I believe. One of the lectures previously I talked about nesting. And the views inside of the views are the objects or the items inside of the views. So this is basically an application of that, but doing it programmatically instead of using the interface builder to start nesting things. Instead, we're using it this way to add a subview of the ball view for each one of the balls that we're going to create. And we can actually kind of determine how many balls and put as many as we want. We just put one of them on there if we wanted to. And that's something that you might want to experiment with it just to see. But it kind of shows you this particular example. It just shows you some animation. And so begin the animation, and we can set up a fast flake, how fast they will fall. Here we've got a speed of random 5 times the speed, and the speed is going to be an adjustment that you're going to essentially experiment with to see in terms of the speed ratio. And we're going to set the position where the flakes will move to, in terms of the frame and the orientation within the scale. And then basically the rest of it is you know, the on animation. When it's complete, what are you going to do? Well, you're going to destroy it. So you're going to release the ball. This is the line it says, and we're going to remove it from the super view. Otherwise, what's going to end up happening is it's kind of a recursive function. If you think about the concept, create a ball, create another ball, create another ball, create another ball, create another ball. Eventually, we're going to run out of memory. So on the complete, and this is another way of, and this is the method header that we looked at in the .h file in the beginning when I started with the text file, the description of this project. I just kind of left that and skipped over to the implementation because this is a little bit more interesting. This is that on animation complete, which means when we're done with the object, let's get rid of it. So when we're done with it, we don't have to get rid of it. We could do something else with it. We could just pile all the balls up at the bottom until the screen filled up with all the balls if you wanted to. And you can actually easily create all sorts of different animations using the same technique. As an example, an hourglass would work the same way. You just move it from one side of the hourglass to the other. So, or in terms of shaking something to get something to move, that might shake your phone and get something interesting to happen. So in here we're just basically removing it from the view and releasing the memory so we can get rid of all those little ball instances, because when we send new ball instances we want to have enough memory to support that. So here we are going to also override and allow the orientations other than the default portrait mode. We've actually sort of seen this, but the should auto rotate to interface orientation, set it to yes, which basically is going to say we can move it so we can go landscape or portrait. So, in fact, one of the PDF lectures that I gave you had all of the different orientation and settings that were associated with profile, or properties that you could set per user, or per device, I should say, device settings. I did receive memory warning. I mean, this is in views, basically puts everything back to the super view on each one of the releases. So. And a dealloc at the end to get rid of any memory that's been garbaged, essentially. To do our manual garbage collection, shall I say. So if I go back to the handy-dandy instructions here, it's going to basically tell us to cut and paste that code I just went over. So we start out editing the interface builder, adding the icon, the view icon, bring up the attributes, change the color if you want. Connect the owner's icon to the view icon. And then in the view did load, we're going to set the color, load the image, set the timer, and then on the timer itself, basically you're going to cut and paste this code and stick it inside of the .m file. And that was the code I just actually went over a few minutes ago. Oops, let's get down to the bottom here. After you put this into the .m file associated with the controller, it's all edited in the controller. Then that's all the changes that you actually have to do, and then the code is given to you, so you just cut and paste and put it in. If you cut and paste and put it in, your complete file, your .m file, sort of looks like this, which is essentially all the functionality. So the entire program itself is running from these two files. You don't have to edit anything else. In fact, the rest of it's going to be the stock stuff that was in there. So, and there's not very much of an interface to this file either. I mean, it's just like that image view that's put up there. So if you run it, lo and behold, you'll get a different pattern. Not that you could possibly tell the difference between all the different consecutive runs, but you did see the start of the ball dropping. So, and it is random. So. I'm sure there's some pattern to the randomness given the seed value, but the finished app sort of looks like that, and that's all one image actually that is being changed in size. I see that they're pretty much all the same size right now, but in a few minutes they'll possibly change, get bigger. I did earlier when I was running this, I saw some bigger. Here, there's a bigger one. There's a big one right there. So. You can play. There's a big one right there too. So you can play around with the randomness function and sort of change the behavior. You can also change the number of balls that get put down here, increase it, decrease it, and then you can kind of see how this sort of runs in a stateless, endless loop as well. So you can kind of also see the animation part of it work. So the purpose of this particular project was to demonstrate the animation components. And the ball dropping is the animation that's occurring with it. Questions, comments, concerns about the ball dropping. And I will include the source code when I upload the video, so you can just click on the text file. And the source is giving you, the text file is giving you all the source code, so I'm not sure to worry about writing it. Whoops, no, ball dropping is still running, so let me stop that. Do I want to save that? You know what, I'm not going to save it, because I don't know what kind of typos I put in there. Not too much to add and drop outside of the icon for the program. Yeah. No, you don't need to on that one. It's all done programmatically. You do have to put an image view up if you, in the interface builder there is a step. The interface builder step is going to be in step number 3, where you're going to add any background color that you want to do on it. Connect the file owner's icon to the view icon, so you can, if you have an icon. All of it's done from within the source code. The ball itself is being created as an object. That's actually quite kind of an easy thing to do, actually, believe it or not. In fact, it's one file, as I mentioned. Let's say, for example, you love that program and you want to run it every day. There's one file, and it's not even put into the resource directory. It's actually being loaded from the... Actually, let me see, where is that ball, actually? No, it is in the resource directory. Here's the ball here, the icon that's being used. It's a PNG file, which means it's an image file. If you wanted to, you could replace the ball with another one, recompile and run it, and it'll throw another one down there. Depending upon what you're putting in there, you want to make sure it's of the same size initially. Otherwise, if it gets too big, you're just going to take up the whole screen. You could, but you'd have to change the loop to accommodate for all of the different balls, because this one is only loading this one. So you could possibly, cut and paste and create duplicate code to run each of 3 different types of balls. Actually, that would work. You'd have, just instead of having one ball showing up, and you'd have 3 or 4, possibly though it might be a little busy on the screen, but you should theoretically be able to see all the different variations from the random generation of those balls. And that would be edited in, well, you'd probably have to edit both the .h and the .m file for the controller to add it. But I would, if I were doing that, I'd probably add it to the same functionality that's here, but instead of creating one ball, create 3 balls. And basically you're just creating 2 more images in addition to the one image that exists, and then add the functionality for the randomness, for the size, and for the direction, and for the speed. The speed is also randomized, so some of the balls are flowing faster than others. So it's applying a random function essentially to an image and displaying the image out using a animation feature, built-in animation control. So, and then cleaning up after the animation is finished. So, I think probably the trickiest part would be getting it to actually give you a nice effect. You can throw anything. In fact, you could replace that ball with raindrops or something, or I don't know. But getting the appropriate effect. You possibly could turn it upside down as well. Instead of going from the top of the screen to the bottom, you could make it so it's fire or something, or smoke coming from the bottom up, I guess. Then it hits the bottom and explodes or something. Actually, they're disappearing when they hit the bottom because they're being allocated. Yeah, they're deallocated. So they're gone completely. So new balls are coming through the system. Alright, so this next activity indicator, this next project we're going to look at is showing another feature of the phone. See this status up here at the top? Kind of a simple example just to demonstrate the concept of now we have it. The activity indicator is basically telling us, wait, please wait. This actually comes in handy for a lot of different things because you want to put this up when you want the user to wait. Although the user can't see anything, the UI has to catch up, or the programming has to catch up with the UI, vice versa. So program had a bug earlier, but it looks like it's working now. Before it wasn't actually turning back on, but now it looks like it's toggling correctly. So as you can possibly imagine, this is a component that you drag on with the UI builder. And this is a component we've seen already that we can drag on. And we're just going to connect the components so that this guy, when you press it, turns it on and off. And it's just a start and an end of the animation that's associated with that. And there's no animation with that. That's a property. Is it moving or is it not moving? That's the property. So I thought I'd put this in here, however, because it kind of puts the pieces together with both I don't know, kind of a fake animation, kind of a status of it's waiting, with some of the stuff. And this one, at this point, will be kind of easy for you because you've seen all this stuff already. Alright, so this one does have IB outlets and IB actions because we have a button and we have stuff to connect. So this one here is the indicator view to tell the user to please wait, I'm processing. And so it uses a spinning, and this object actually is called a spinning gear. There's other UI outlets, other waiting things that you can actually put in. You can put a progress bar in there, one that where it goes from left to right. But this one here is kind of popular. It's used a lot, actually. So you create a view-based application again, as we've previously seen in some of the other examples. Give the name activity indicator, call it whatever you want. In the Xcode, Xcode's automatically going to create the directory, yada yada. Expand the classes, and notice that the interface builder created an activity indicator view controller class. So unfortunately, this is a lot of repeat because you can do them independently. So after you've read about 5 or 6 of these different descriptions, you go, oh, they all read the same. They do. So expand the resources, and notice that the template generated a nib file. And the nib file is actually another word for the XIB file, which is the activity indicator controller file, which is what we're editing. Same as the last project. We're going to edit the controller file. So in step number 4, you actually get to do something. You get to open up the activity indicator controller and add the IB outlet for the indicator view, controller view, and add the IB action called press me. So remember the action and the outlet that we've seen last week in a couple of different examples. It's the same concept over again, where we take the action that we're going to connect to that GUI button, which is a rectangular button, and we're going to have it do the action of, we connect the outlet and we perform the action on a button that's going to change the characteristics of the status indicator. So we're cut and paste, put this inside. What is this going to do? It's going to give us our method for the IB action, which is going to be press me. Press me gets pressed, which is the button that we're going to call press me. It turns on and off the indicator. So in step number 5, we're going to double click on the activity indicator controller XIB file and open it up and add these components. And let's just go ahead and take a look at that right now. In fact, this is the easy part after we've gone through many different examples. What you're going to do is drag and drop from the library. This should look familiar to you at this point because we just did this last week and you did this, hopefully. So we go back to this same old interface builder as before. We bring up the library. We take a rounded rectangular button, which is what this guy is here, and or we go in here and we go rounded. Here we go, rounded rectangular button. We put it on here. We go into the inspector window. We look at the inspector window which is going to give us our properties. And we see with the touch up inside is the file owner's press me. So we clicked on file owner. We see we have in here that's specified from, big, press me. Where press me come from, first in the .h file, it's implemented in the .m file. It's the action that's associated with the IB action that's associated with this button. How is it associated? Because we dragged this and connected it, as we saw last week, how we connect items together. So all this stuff kind of is the same stuff over again with different examples. But after like the 25th example or so, it starts making sense. Oh, it's the same thing over. It's the same thing you're doing. So we drag and drop and we connect the items together, and we actually only have to connect one item. It's just the action. What is this guy doing over here? Well, he's the activity view, and this is the item that we pulled out of here. Activity indicator, and we stuck him on here. Well, now we have 2 buttons and 2 activity indicators. And we can set the properties for this guy and look at it in the inspector. And we can see he's a large white. You could change the style to gray if you wanted to. That's a small gray one, or a small white one. Can barely even see that now. I changed it. I'm not going to save this, so I don't have to worry about it. But if I wanted to, I'll put it back on large white. There we go. Now it's bigger. It doesn't actually drag and drop. In fact, you can do this with the Android, but you can't do it with the iPhone. It's actually change the size of the sucker. But you can change the size of this guy all you want. He gets bigger and smaller, which is kind of interesting because these guys you can make bigger because they're images. They come in as a different type of GUI item. But you can change it programmatically in style. You can also extend the library, add some different styles to it if you wanted to. But anyway, I think at this point we all kind of get the interface builder, hopefully. If not, let me know. Now is your opportunity to ask questions. I'm going to quit the interface builder though. And don't save because I put a bunch of stuff on there I don't necessarily want to repeat or don't want to show. So that was the step for the interface builder, and the interface builder was step number 4. Oh, no, it was step number 5, excuse me. So you can follow through these instructions if this is the first project that you're building and figure out how you're supposed to add the GUI components. In step number 6, we're going to make the following change. We're going to add the functionality. What's the functionality going to do? Well, I'll take a look at that in a few minutes. And step number 7 at the bottom of the screen here is compile and run it. So it's actually kind of easy. So let's take a look at the functionality. These are the 2 files. This has got the IB outlet, which is going to be our activity view, which has got that little thing that goes around in circles. And then this is the IB action on the press me button. Press me button. When we create the item, make sure to give it the properties press me and write ID number if we're going to use a number for the ID. That way we know which GUI component we're actually talking to. In that particular case, it doesn't really matter, but in other cases it might actually keep track of what you're calling things. Here we have the implementation in the .m file of the controller, and what we're looking at here is the implementation of press me, and it's just nothing more than a toggle. It says, is it animating? Then start it. Stop it. If it's not animating, then start it. So start animation, stop animation. And it says, this is actually a method call we've seen before from Objective-C on the method to activity. On the object activity view, call the method stop animating, start animating, stop animating, which is how we're essentially toggling the behavior. Not need to look at any of this other stuff. It was not part of the code that you're actually cut and pasting. This is something else that was in here. The other things that are in here are sort of like a try and catch sort of expressions that are put in here to check the status. As an example, did it receive the memory warning, in terms of the release of the memory of the object, and the object goes out of view. If it received it, then you do a release the view, so it doesn't have a super view to it, just get rid of it. When you start nesting, you'll see this is actually being put in by default in terms of a lot of the examples that you'll look at and inspect. If you leave it out, the program will learn just fine. But it's kind of like the difference between putting in a try and a catch and not putting in a try and a catch. So if you put the try, this is not, it's equivalent in terms of the behavior of what it's performing, but it's not the equivalent. It's kind of a different concept because this is actually doing, should it be released or should it not be released? On different states, and this has to do again with the life cycle of the application and the objects that are being disposed of in the application and the views. And it cleans up the memory between the different views in terms of the nesting. So this is basically going to clean up the super view. And then, did the view, did it unload? Did it release? Not release itself, and then do a deallocate on it to release the memory. Basically, when you're done using those objects that are on the screen, that performs the cleanup for it. And if you go back to that memory management / garbage collection lecture, the PowerPoint that I gave you earlier in the course, you may have missed it actually. You'll see actually all three of those things demonstrated. So. But that is the press me versus don't press me. We could have easily changed the label to say, turn it on, off, in terms of the activity. So that's all we get for this one. Not too much into it. That's why I say I got 5 of them because some of them are kind of small for today. Oops. Close this out. I don't actually have to close things down, but I decided to. It was much easier to demonstrate stuff and actually have it work reliably if I close down in between. Show IP address. So this is interesting because this is actually showing one of the features of the phone itself. Looking in terms of, creating an again, the interface is extremely simple. All it's doing is putting a label out there along with another label that says, here's the IP address. And then we're going to update the label of the IP address on the load of the application to show the IP address. But it's not going to show the IP address in the emulator. If you load this application on a real phone, it would show it on the phone. However, the emulator doesn't have an IP address. Although you have internet access, you don't necessarily have the same concept. It's using a bridge from the host computer, and it's not setting it actually, probably for protection purposes, it's not going to show in the emulator. So in this particular example, we're going to check the IP address in the phone. Why do you want to do that? Well, if you wanted to write a networking application and you wanted to see the IP address or use the IP address of that phone for some strange reason, you can get it. In fact, this is just an example showing you how to get it. Again, we're going to create a view-based application using the template for the view-base. Give the application name, IP address check, and then Xcode automatically creates it, yada yada. Expand the classes out, you're going to see the yada yada yada. Check view controller, yada yada, same thing as before. We're going to update the view controller.h and the view controller.m file and the view controller.xib file. So this is where the lecture starts getting a little redundant, so I can, after I say it about 20 times and you go, oh, it's the same files over and over again. Believe it or not, most of the applications run this way, actually. You're going to have the same. This doesn't really have too much of a GUI, so it's all through the controller that we're interested in. If we go back to that MV, model view controller kind of concept, it's all control. That's what we're looking at in terms of these examples. So we're going to open up the view controller. There's an extra space there. Add the UI text view. We've seen those already for displaying the text. Make the following change. Cut and paste to put this code in here. What are you putting in here? You're putting in here the identification of an IB outlet. We've seen before, the IB outlet is going to be called the UI text view. The UI text view is going to be identified by the pointer text view. Then you're going to double click on the XIB file. I'm going to put that on the canvas. Drag one over, type in text view in the library, take the object, drag it over to the canvas, connect the component. So the trick is you got to basically update the .h file. You don't actually have to have the implementation completed. You don't have to have the .m file filled in. For this particular one, it doesn't even have anything outside of an address that we're going to put there. But you don't have to implement the IB outlet or the action. All you have to do is create the interface to it through the H file before you go and do the GUI part of it. However, by practice, I sort of like to do both first. If it doesn't show up in the owner file owner object, which is the object that's being created for the view controller, it means there's a problem with the source code. Source code is not compiling correctly. Because if you haven't, you don't actually compile it before you run it. You can actually put in really bad source code in the H file and in the M file. Go to Interface Builder and build an interface with the bad source code. the problem is it actually, for some strange reason, there's like a pre-compiling stage that goes on or something, and it won't let you connect. It won't even show it if it's not compiled correctly, which is kind of weird. It's kind of one of those odd things about the development environment. It should automatically compile it for you, you'd think. Because the Android operating environment, actually development environment, that will show you with X's, with red stuff highlighted constantly as you're typing, which is kind of irritating. This is the exact opposite. Instead of showing you anything that's wrong at all, it waits till the very last minute till you want to actually run it, and then it says, oh, you have a problem, which is exact opposite in terms of the philosophy of error checking than the Android system. Anyway, and just put that in there for whatever. Step number 5, see, double click on the XIB file, open it up. Connect the file owner of the text view, and we'll look at that in a few minutes, save it. Go back to Xcode. Number 6, put in the m.m file. What is in the .m file? This is the implementation of that. And the implementation method isn't going to do very much. It's going to set the text view at text to something. And it's going to set it to nothing to begin with. So on the initialization, and this is sort of the constructor, init with nib name, on the construction of the nib, and on the interface, it's going to put a blank nothing, make the label blank. And then we're going to run the method to get the address, and the get the address is going to essentially, this is the source code part. So we have a character array called iPhone IP. This is as big as array as we possibly can make in this environment. We're going to string copy. This is regular old C++. And this is the string, this is localhost 127.0.0.1. We're going to put that in here. We're going to make it my host is equal to, and this is going to be the, we're going to get this object, we're going to create this object my host, which is going to be the current host, which is going to get it from the actual host of the iPhone, which nothing more than running the method, who's our current host, and copying it to this variable. The variable, we're going to check it, and if we check it, we're going to put the actual host onto the label, into the text of the label. Otherwise, we're going to return it, and we're going to put the IP address of localhost in there. So it's going to get one or the other. It's going to get either the host that's on there, or it's going to get the local address, local 127.0.0.1. Why do we want to do that? It's actually a demonstration of a nice way of setting it so that the IP address is a valid address. So if you're creating an application and it can't read, and then going back to that try-catch kind of thing, it's kind of a makeshift test to make sure you have something in there. If it's this, if it's that kind of thing. Anyway, so this is going to add the address for my host, and my host is going to be the address coming from the phone itself. Otherwise, return with a string and basically set the iPhone IP address to the actual address of the particular phone. And then lo and behold, on the bottom here, the view did it load correctly. We're going to set up another object address, which is going to be an NSString object, and the string object is going to have self get address. And then we're going to have another object, my IP address, which is going to be equal to the IP address object itself with the address. And then we're going to set the text of the text view to my IP address, which is going to be the IP address that we got. So basically, we're running a method call on the host to get the current host, to get the information, and then from the current host, we're pulling out the IP address. So now compile it and run it. Should run just fine. You'll see the output on the iPhone. It's not going to show the actual output in the simulator because we don't actually have a host. It's the local. So if we run it, actually, let's take a look at the interface builder real quick. The interface builder is not going to be, because we just looked at the code a few minutes ago, it's not going to be anything too exciting. It's just going to have a label on it. Yeah, a bunch of text on it. I'm not quite sure what that is, actually. Let me make sure I have the right example running. Ah, there we go. The IP address label with the IP address on it. So this is just a label. I believe I pulled up the wrong example a few minutes ago. No, actually, this is a label with a bunch of crap on it. So this gets replaced with the real label. So it doesn't really matter what you're putting on the label because it's going to programmatically be replaced by the IP address. And the IP address is going to be written as IP address. This is the part that's being added to the text of the text view. And this is the text view that's out here. And this is not going to show, this is going to look like garbage on here because we don't actually have an IP address that we can get from the emulator. If you were to take this program and load it on a real phone, it would actually give you the IP address of the phone because there's a host that actually can get the information from. So. But that is an example of how you would get one of the properties of the phone. You could also do it with all of the other items. A couple weeks ago, I went through a PowerPoint or a PDF file, I believe, that showed you things about the owner, the name of the phone, the status information about the phone, whether it was in landscape or whether it was in portrait mode, all of the different properties that are associated with the settings of the phone. This is one of them, the IP address of the phone. So you can actually go through and pull those settings out programmatically by running the appropriate method on the appropriate object. In this case, we're running it on the host object. It's giving us the IP address. So, kind of a fast run through. Any questions on that one? Kind of an easy one, actually. It's just the next one's going to be just as easy. I'm sorry? How can you run it on the iPhone? Interesting, interesting. You need to get a developer's license and a certificate. Well, it's you have to download something. In order to get that, you have to pay Apple. How much do you have to pay Apple? About $99 a year. Not too bad, actually. You have to sign up, and you have to sign a developer's license. You can actually get. Let me see real quick. Now I'm kind of curious. In the old days, teachers used to be able to get it and give it to students. It was called an educational license. Hold on a second. Let me just do a quick. iPhone license. University program. iOS University program. Developer University program. I don't believe a student development team. I don't believe each individual student has the ability, ever had the ability to get one of these. I think it had to run through a university. And even when you do that, it only works on one phone. In order to actually get it to work on multiple phones, you actually have to pay for a full agreement, for a full license. And it's an annual subscription that you're doing to become a developer. Once you become a developer, and then you can fill out and apply for to have it added to the market or to the Apple Store. And when you add it to the Apple Store, then it becomes available to the public. However, you have to apply and provide correct information, and there's a process that you actually have to go through. A little bit more entailed than the Android process, and there's a fee associated with it. Not quite as easy. You cannot take the finished product. The key, there's a hidden key on the app itself. You could take it loaded on a phone, but it's not going to run. This is going to tell you there's a violation, or there's a key missing, or there's a problem with it. And it's only because you haven't paid your $99 and you haven't downloaded your certificate and you haven't attached it to your phone. If you do pay your $99 or your free, you do get the free educational one, which I believe I have to do for you. And I'm gonna actually let me add that to my to-do list for this week, so that next week I can have that available. If you do that, what it allows you to do is just take and load it on one phone. But I have to go look and see. It's been years. It has to be my phone probably. I can load yours on my phone, or I can demo to you how to load it on a phone. But you have to pay $99, I think, a month, or excuse me, a year. But let me actually research that because I haven't looked at the current fees. This is outdated information. I haven't actually looked at the current prices. Yeah. Yep, no, not a bad idea. It's just a little bit more entailed. It's a little bit more complex, let's just say that. You can't just take and run through, take that app and load it on your phone. It's not going to work. Because it's going to complain about a missing certificate, actually. And the certificate is a code that makes the app work. And the code you're going to get is going to be for your phone. So as an app developer, if you don't have a full distributor, you just have a single developer thing, which I believe is the $99, but don't quote me on that. I have to go take a look at it now. You can put apps on your phone. You just can't give it to everybody else in the world. And in order to give it to everybody else in the world, it's got to go into the Apple Store. It's going to be approved by Apple. And you have to have I think you have to have an upgraded, slightly different account with them. But don't quote me on that. That's my homework. I have to look that up. But that was a very good question there because I hadn't talked about that yet. I'm sorry? Not till June 16th. But it'll be, yeah, absolutely free. One day. Are you going to the Android one? There's an Android workshop. Now we have a commercial break. We have an Android workshop that's absolutely free. Yeah, that one is coming up actually in 2 weeks. That one will be on March 31st from about 10 to 3-ish in the seminar hall. Open to the public. Anyone who wants can show up for it. One day, just getting, it's installing the developer tools and building apps for SMS text messaging, the database features, and something else. I don't want to get confused with iPhone and iPhone. But I will have a very similar one on the iPhone in June, on June 16th. Yeah, it'll be an all-day kind of thing. All right, so the next one that we're going to look at here is the touch event. Although it's hard to touch it, however, we can use the mouse. So the touch event is going to demonstrate, let me just show you this one actually, the moving and the non-moving of a ball. And it's the same ball as before actually. And what is this guy going to do? It's going to look at an event again. The code is recycled. You push, and if you touch it, touch stop, touch begin. I'm clicking my mouse actually. I'm simulating a touch. But on the back view, this is the one that's broken. Yeah, I just broke it. The ball doesn't bounce anymore. This one's a little buggy, but you can see the touch event on the back is changing the label. So let me actually start it to refresh, and you can sort of see what's going on in the beginning before I broke it. So just ball just moves a little bit. It's a little too sensitive. However, that's a mouse click, not really a press of a finger. But it's supposed to be controlling the touch sensor. And the example is the same code as before with the ball, except for it only puts one ball out and puts it up, going up and down. It doesn't do any randomization of the ball. Instead, it just captures the events that are occurring while the ball activity is going on. It captures a touch. So you've got two things going on simultaneously. So what are you doing in this particular example? This example's got, we push the button and the ball will move up and down. We got that one. And the application detects the touch event also. So it's a button-controlled ball instead of a random ball. So we're going to create a view-based application just as before. And give the application the name touch or whatever you want to call it. Yada yada. Let's go into the open the view controller, same file as we were editing before, the .h and the .m of the view controller variety. Cut and paste and put that in here. What do we got? We got the IB outlet for the view, which is that background that we saw, and the label. The label is the background that's on the view. And then we're going to have the IB action. The IB action is going to be the button. On the button, we're going to have a push to start action, which is going to start the ball moving up and down. And then in step number 5, we're going to put all of these items out on the canvas. I don't really need to read this to you because I'm going to show it to you in a few minutes. And then perform and make the following change to the .m file, which is basically going to cut and paste and put in the implementation of those methods that we have specified out. And the implementations are going to be on the UI view. It's going to begin an animation. It's going to set the animation duration. It's going to set the current state of the animation. And this is really the heart of the example in terms of what I wanted to show you. It's basically setting on the view the animation for the capturing of the touch. All of this is for a single touch. However, you probably would make it for, moving things around. You can control the drag, the touch up, the touch down, all of the different concepts, but on a view rather than on a button. So the concept is you're touching the background of the application in the view window instead of the button. So it's the same concept, however, you're just attaching it to a different component of the UI builder. So here we have the touch begin, the touch cancel, touches end, touch moved. And you could possibly see with all these different events, with using the mouse, why it's kind of, the button doesn't work after a while because it's good. I think it personally is getting confused, but we'll see. The code is kind of trivial. Here's the code here. It's just setting the different states to capture the different events. What it's doing here, it's supposed to be changing the text. However, I can't really demonstrate this with a mouse because we're only getting one event occurring. However, you could have a touches stopped, touches canceled, touches drag detected. In fact, that's a good test. Let's see if it actually picks up the drag. I don't think it's going to pick up. I don't think I can simulate a drag with a mouse, but let's see. Yeah, drag detected. I'm pressing down the mouse and I'm dragging it, so drag detected. So we have you can't see it because it goes a little too fast, but touches starts, happens begin, starts with a start, and then it does the drag, and then it's going to do the end, stopped, touches stopped. These are all of the different states of the touching activity that's occurring that I'm simulating with my mouse right now. And oh, now it's working. Okay, good. So, oh, no, see, the ball just stops intermittently. And then the ball just doesn't work after that. But as you can possibly tell, there's a lot of activity going on in the window. It's kind of, it's not going to actually, the ball is on I believe the ball is not on a timer either, which is probably the case as well. So the ball is not on the timer. So the ball is not going to continue going. It's just going to go for as long as it's supposed to go for. So we take a look at it. The most interesting part of this code is actually the interface builder, because the interface builder is going to have the objects for the capturing of the events for the touch begins, touch canceled, touch ended. And the purpose is essentially to show you by this text display all of the different states of the touch and how this touches can change states. So we take a quick look at the interface builder here. Oops. Get to the right one here. Here it is. We have the label and the. Oops, there we go. You see, we have the image here. The label is here. The button is here. The button event for the file owner should be set. Touches labels on the label touches, the views on the image view. Push to start, which is the rounded button, is on the activity of the ball. So that is the IB action that's being captured by that outlet. So if we were to connect the dots on it, oops, where'd the interface go? Here we go. Here. This label here is going to be the touch up inside for the push to start. Oops, excuse me, it's going to be the action that's going to be associated that's going to be done programmatically and not through the interface builder. So the only thing that's done through the interface builder is this action here. So the other outlets are done programmatically. In fact, it's just capturing the event and changing the label on the events that are occurring. Because unlike the Android environment where we attach a listener, we don't have to attach a listener and listeners there all the time. We just have to call the methods on the object, and we're calling it on the UI view here, object. call the methods to capture the activity that's occurring in terms of the button, or I shouldn't say button, touch presses that are occurring. All right, last but not least, because we gotta get sick of these examples after a while. I showed you a list box. In fact, the scary bugs was in the form of a list box, and that was not a bad activity to go through. This was just a slight variation of the scary bugs, except for instead of putting stuff in the box and you clicked on the box and it brought up another screen for you, this one you click on the box, it selects it or it doesn't select it. It's kind of like a checklist. Here's this little grocery list, actually. I should say cheese, butter, jam. But you can see as I'm clicking on the box, the behavior that I'm looking at is that the button image is actually changed. The image button is changing from a selected to a not selected looking button, which is just nothing more than, again, a click activity. And the reason why this weird. When I zoom the get these to look, can I move the buttons? Oh, wow, interesting. Okay. The on the Mac, the zoom in, zoom out is the alternate control command. Oh, now it's not doing it. So, a few minutes ago, it was putting those two little buttons, those two little dots on there. Okay. All right, so let me demonstrate this here to you. So if we take a look at the code for it, what we're looking at, so in the application, we're going to basically have a UI table view. The table view is just going to be like our scary bugs that we looked at the beginning of the course. And then we have a checkbox, a check mark button that's on the end. It's an image, so we're going to create a window-based application. And we're going to name the application checkmark. And then we're going to go and take a look at all the files. And then we're going to see we have two images. We have a checked PNG and an unchecked PNG. And you can possibly imagine what's happening. When you click on the item, it's taking the event from the click and changing the image from the checked to the unchecked, to checked to the unchecked, and vice versa. So the code is actually kind of trivial. So you'll have to add a table view controller. We did that already with the scary bugs. So we choose select Coca touch group and then add a UI table view controller subclass. Give it the name table view. And then we're going to edit this side. We're going to edit the appdelegate.h file. And we're going to put in the controller for the appdelegate because now we have an appdelegate because we are in a window-based application, which is a different type of application template. That's one of the menu items that you select from when you first go into Xcode. In the appdelegate, we're going to have inherited from NS objects. We're going to have a window. Lo and behold, yes we do. And we have a window controller, which is our navigator. And then we're going to have the IB outlet for the window, the IB outlet for the navigational controller, which is the controller is going to be that the box with the multiple items in it, the text view. And then in the appdelegate.m, we're going to put in the source code that matches the .h file that we just created in terms of the templates for those particular classes. So we have the application did finish loading. Did it finish loading? Then we're going to clean up any mess. We're going to make it visible. So we're going to make key and make it visible. And then add the so we added a data array to the text view.h, and the data array is going to have those items that are going to appear on the menu. So we take the table view and we add to it an array of strings, and the strings that we're going to add to it are all the items that are going to be in the list. And then the initial states, or whether they're checked or unchecked. I think by default they're all being checked. So. Then we're going to add those components to the interface builder. We've actually seen that with the scary bugs. In fact, it's the same interface. We did, in fact, probably a little bit easier. We'll take a look at that if you're interested. In the table view.m file, we're going to add the following code. The following code is nothing more than taking the properties, setting the properties for each one of the images that are going to be associated with the table view for each one of the items. Making it checked or unchecked, setting the view itself, taking the string of the to-do list or the grocery list, adding it to each one of the items, using an array actually. So taking the and getting a count of how many items are in there, so we know how big to make the view, or how many items we're gonna add scroll bars or something like that to it. So this is the data array. The data array is going to essentially set the property essentially of the text view to store each one of the items. And then we're setting a string for the custom cell ID so that we can know whether or not, and we can keep track of whether or not the item has been clicked on. So we can keep a count of how many times it's been clicked. So we click it once, unchecks it. Click it twice, it can do something else if we wanted to, but this is not doing that actually. Instead, this is just we're doing an on and an off on it. Checking a checked versus unchecked status, and then if it's checked, after we check the status of it, changing the image. So if it's checked, we're going to put the image for the checked. If it's unchecked, we're going to put the image for the unchecked, in terms of a PNG image that's going to be shown on the UI image. This is nothing more than changing the UI image. UI image is the same as the ball, believe it or not. It's just an item component object that we're adding. So we're only adding one per line, but it's the same item that's being added line by line, same as before. So then we have the UI button, and the button is going to be the check button. So you can click on the button, it's going to essentially, so if the check button is tapped, it's going to say on the tap, take a look at the object. If the object is this, change it to that. Otherwise, return it back. So let's see. So what you'd want to do is essentially cut and paste this code, put it in the .m file for the table view, tableview.m file, and which is going to be the same as process as before. Launch the application. We'll take a look here for a second at the we have our checked, and it's kind of small, you can't really see it. It's a small little icon. It has to fit on the screen, so I mean, it's not going to be that big, but we have our checked and we have our unchecked PNG files, and that's going to be used. Here's another list that was actually done from a different example. That's actually populated because the example has been transformed from another example that I gave you a couple weeks ago. So in my particular yours isn't going to look like this if you build it like this, but this is just an original list that's been put together, that's been changed programmatically, because we're going to set it from an array of data items that we're going to take out of a string for these guys here. Essentially, they're going to show up. So when you run it programmatically, you're going to see essentially this output here instead with this behavior. And it's nothing more than looking at the on-click. So if we were to open this up in the interface builder, which I had a few minutes ago, here's the navigation controller, and the navigation controller is this box that's going to be controlled by the app delegate. So the delegate's looking at the table view and in terms of its contents. Oops. So what you do is you'd drag a table view over from the library, connect the add these, you can programmatically add some items to the table view, or leave it blank if you wanted to, and then connect the click, which is actually not something that you have to connect. It's actually done programmatically. So there's no buttons or anything on here, so you don't have to worry about any type of action that's associated with it. This event of clicking the item itself is going to automatically come through. So, as I was mentioning before, the listener for the click is given to you automatically. You just have to catch it. So you don't have to add a listener like you would do in a normal, or in an Android type of environment. So, and that was the last example for this evening, which was the check marks in terms of the on and off. So what I'll do is when I upload the video, I will also upload these text files that go along with it. Oops, actually this is the one I want to close. So that you have the information. you'll have to improvise a little bit with the icons and things, obviously, because when you load it, you're not going to have those icons. However, you can download icons and put it in there. All you have to do is make sure you match the same name, load them into the same directory as the class files, the .h and the .m files. They don't go in a resource directory. However, if you did put them in a resource directory or in the other directory, they would probably load just the same way. So as promised, I'll let you out on a reasonable time tonight as well. So questions, comments, concerns? Have you guys all looked at the assignments that are due for this course? Okay. And you started, that's very good. Because you don't want to wait till last. They're actually kind of easy, aren't they?
Yeah, that's what I'm thinking. Like, if I understand the code, can do.
They're all like the tic-tac. I think I did a tic-tac-toe one, didn't I?
Yes.
That one is just the same as, you know, did you click it, did you unclick it? So you put a bunch of images and you switch the images from a X to an O to a blank on each one of the boxes. That's a click. The tic-tac-toe is a click action oriented or press touch. So you have an IB outlet that does, you know, puts the images out there. And each one of them is the grid. So you have first, second, third, and you can take turns between. Or you can have the computer play the person. So. And as I mentioned earlier for the Android people, the final exam for this particular course, all assignments, if you haven't started on them yet, are going to be due on May 1st. The final exams I've decided that are going to be on the 23rd and the 25th this time around. So if you're in the Monday class, which is tonight, your exam is on the 23rd. If you want to take it on the 25th, you can. So what I normally do if you're brand new to me is if I have classes on Mondays and Wednesdays and I have a bunch of classes, like two classes here, well, only one on Wednesday actually, I open up both days from 10 o'clock in the morning until 3 o'clock in the afternoon. You can come in and take the exam whenever you want on either day. You can come in and take it twice if you want. Why would you want to take it twice? You only have to take it once. But you can show up on one day and take all of them if you want. So if you're in this class and the Wednesday class, which I think you are, yeah, you can take them both on Wednesday.
Or it's both on Monday.
Or both on Monday. Does that make sense? All right, sign the roster if you haven't done that already, and we're all done for tonight. No more torture. We're done.